Hello, this is the practice for 6.3, summation intuition. So before we start, what you need to know for this is the definition of the integral in terms of summation notation. So there's going to be a limit and a summation, and then it's, for me, what I think of is the width of the interval of each tiny rectangle. So it's going to be b minus a over n, that's the width, and then the height, and that's going to be the function evaluated at big jump plus the small jump as many times as we've gone through. This is how I remember it, and then I can go backwards and feel what I'm missing. So the small jump is k. That means that k is our counter, and it goes from 1 to n. N is the number of intervals, but to make it an integral, that goes to infinity. And if you don't know what I mean by small jump and big jump, you can ask me again. But again, I think if we're doing an interval like this, and we have all these little rectangles that we're doing, for me, this is the big jump, and that's the A, and then as many small jumps, so that's the width times K. Anyway, I hope that helps, but if you need more help with that, let me know. Right now we're going to move on and start solving problems. And of course, all of this is equal to the integral from a to b. So here we have to somehow map this expression to this. And the way I like to look at it is what works. So right now, this and this are the same, so we don't have to worry about that. This and these are the same, so we don't have to worry about that. Then what I see next is this. This and this look pretty similar. I have a quotient over n, and so what I'm going to do is, since they tell us the lower limit here is 0, I know that a equals 0, so this is what it means, a equals 0. B, since this is b minus a, that has to be pi, from 0 to pi. And then let's keep looking at our expression. This here, there's a k here and a k here, so this b minus a over n is the same as it was before right here, so pi over n, that's also accounted for. A, in this case for us, is 0 in this example, so then we're left with f of b minus a over n times k has to be this. So that means that the f has to be the cosine. And then we are done with that mapping. Okay? By mapping, I mean being able to see what's similar and what's different between these two expressions and figure out what's missing. Okay. I don't know how to, let me see if I can clean up that like that. Okay, so to the next one, it's going to be an integral, and they tell me the lower limit is -3. So again, this is accounted for, if you will. This is the same as that. So then this has to be the same as that. So that means that b minus a has to be 5. So this means that we're jumping 5. That means that this is going to be 2. From -3 to 2, that's the 5. And then we're going to go here, and this is the same thing that we have here, but times k, so that's good. That's my b minus n times k, all of that. Oops, all of this is there. And then I'm missing something, so the a, we already know it's -3, so that's going to be that -3, but it's also this a here. That seems like that's our a. So then whatever the function is around it, in this case, this whole thing has to be our f. So this is going to be cube root of x dx, and that would be the integral that they're asking for. Okay. Again, let me see if I can clean up this a little bit so I can keep making this explanations. And maybe you need less of that as we keep going. Okay, so here, again, these two things are always going to be accounted for. So this is b minus a, so the integral from the lower limit to 9 more, so 6 to 15. And then this is already my b minus a over n, the width of the interval, the number of steps. So this is my a, so all of this goes into my function, and it looks like my function is just 1 over x squared. So 1 over x squared dx. Okay. In these problems, we're going to go reversed. We're going to go from the integral to the limit. So the limit, the summation, this is always n infinity, and this is k from 1 to n. And now the first thing that we need is b minus a, so the difference here. So that's going to be 6 over n, and in my mind, this is the width of the small, of each of those tiny rectangles. Each of these rectangles has a width of 6 over n, because this is 6 and we have n subintervals. Okay, and then what comes next, and maybe I'll do it in 2 steps at first. So then what I'm going to do really is, let me just write the whole thing. b minus n over n, so width times height. And height is going to be the function evaluated at big jump plus k small jumps. So with that there, I can rewrite this and say that b minus a, we said it was 6. And then the function is something squared. That's what this says. And then what I have to square is a, so a is -3, plus b minus a, so this thing appears again, so it's going to be that times k. And that's it. Same thing here, I have the limit of the sum. And then the first thing is the width of the interval. The width of the interval is going to be 5 minus 2 over n. And then I'm going to do times the height. The height is going to be f of, so f, I don't need to write f, I can write f. This is f. And then what do I have to plug in here? Well, I have to plug in the big jump, that is a, plus a bunch of small jumps. That's the width of the small jump, so it's going to be that times k. And that would be it. Similarly for this one, is going to be the limit of the sum of, first comes the width, so the difference of the two, the width of every tiny slice, and then the function times the height. The height is going to be the function evaluated at big jump, so that's a 0 plus, that's the big jump, plus k small jumps. Which of the following expressions is equal to blah, blah. So here we don't have the summation notation because the summation is expanded, but it's the same thing. There's the limit. So first, this here, this 1 is b minus a. So I'm going to guess that that is not d. That the difference between those two has to be 1. That's the first thing I notice. Okay, next. Well, the function is going to be e to the something, that's for sure. Now, we still don't know what a is. So now there's a question of whether if this one is or a, or if it's part of the function. So let's first look at this. So the 1 over n, that's 2 over n, 3 over n. So that is the b minus a over n times k. That is accounted for. And now I think we can choose either or. So either a is 1, and then we'll get the integral from 1 to 2 of e to the x dx, or if a is 1, it'd be the, yes, or a is not 1, and that's part of a function, and then it'd be a is 0, and then it'd be from 0 to 1 of that function. I hope that makes a difference. So it could be either of the two, but in this case, that is not an option, so it has to be this one. And again, the difference is, before sometimes they tell us what the lower limit is to make this easier. In this case, they didn't, so this one here could be a, so the big jump, or it could be part of a function. So let's do another example here. When I look at this, the first thing I notice is this. So it looks 3 over 7 is going to be b minus a over n. So we know that n is 7. That doesn't appear anywhere here because that's just the number of intervals that we're using to approximate, but b minus a has to be 3. So that's a good sign. That's a good sign, and that's all of this have an interval of 3. So for now, I'm going to scratch that. Okay, next, well, the function is going to look like, okay, then when I multiply, so this thing here is going to be b minus a over n times k. So what I already had here times k, but so I can see that this is times 1, times 2, times 3, so this works. So that's going to be my x. Except what I see here is that this same x appears here too. So our function is going to have the x twice. In this case, actually, it's going to be x sine of x. And then the integral, in this case, since there was no plus in here, this is our x. That means that there's no a plus. So that means that a is 0. And we said that the width was 3. So it has to be a. I hope this explanation is clear enough. Maybe I can find, I haven't found yet a different way of explaining this that's not like checking by parts. Yeah, if you're confused about this, let me know. Okay, one more. Similar, I like starting from here, where that is b minus a over n. So n is 5, but that's one up here. That doesn't give us a hint, that's the number of intervals. But b minus a equals 1. So this difference has to be 1. That's not 1. And that's not 1. So I'm going to guess that it's going to be A, C, or D to begin with. Okay, next. This same thing we see here, the 1/5 and then 2/5 and then 3/5. So that is our b minus a over n times k. So that's our x. And now it's time to decide whether these two, if it's part of our function or if it's the a. It could be either, I think, with the information that they give us, so we can try both. So either the 2 is the a, so that means that with an interval of 1, the integral from 2 to 3 of ln of x dx, or a is 0. Actually, there could be other values, but here, these are the only option. X could be 1. There's something, so others in between, but we don't have that option here. So either x, a is 0, and then with a width of 1, so it could be from 0 to 1, and then in this case it would be 2 plus x. So again, the difference is whether this is the a, the beginning of the interval, or if it's part of the function. And then it could be either of these two, but here, I don't know whether it's an over 5 here, that doesn't work. So that 5 is the number of sub-intervals, and should it be an integral? And this, I think that's the same 5 here. We don't need that. So it has to be this one, D. Okay, moving on to test prep. Which of the following definite integrals are equal to the limit of the sum of blah, blah. Okay, so in this case, again, I like starting from here. So that means that b minus a equals 4. So right now, yeah, I might be confused because this 4, I was going to say that b minus a has to be 4, but this 4 could be, I'm surprised by that 4. It could be part of the interval, so it might be a little more tricky. Let me see. Okay. Well, we also have this here. Oh, yeah, very tricky, very tricky. Maybe we can go backwards and start from the 3 options. So if we were to do this one, this would be, I think this is a tricky question. So I'm going to do b minus a, so 4 over n, and then times the function, and the function is going to be squared from a, so -1, plus the small jump, so 4 over n times k, and that seems to, if we change the order of this, that seems to work, so I'm going to say that 1 works. For 2, I'm going to do the limit of the sum of b minus a is still going to be 4, so 4 over n, and now the function now looks like this, -1 plus something squared. Let me make that smaller. So -1 plus, and this is our x here. This is our x. And in this case, in the x, what we have to plug in again is the a, that is 0, plus our jump, something like that. And that happens to give us the same as before. So this one works too. And then lastly, for the third one, and I think this is the trickiest one because of that 0 to 1, that might be confusing, but I think it's going to work also. I'm going to do b minus a, so in this case it's only 1 over n, and then times our function, and the function is going to be -1 plus 4 squared, and this is where our x goes. The x is going to be big jump, that's 0, plus small jump, and the small jump is going to be k over n. And 4k over n minus 1 squared. Oh, I forgot that. I forgot about that 4. So actually that's part of our function, and that's what fixes the problem, yeah. So we get exactly the same thing, so that one works too. Again, I think this one is the trickiest question of what we've done because of this part here. Is that 4 there that makes this be a 4 over n that looks like these two, even though the b minus a is 1. Yeah, that's the trick one. Anyway, so that's that for 6.3.